Okay. Couple of questions here. A map has a scale of 1:500,000 and two peaks are 2.1 centimeters apart on the map. What is the actual distance? So again, what we've got here is that 1 centimeter equals this. We want to know what 2.1 centimeters equals. So we've just set it up in this little ratio type. We times this by 2.1, so we times this by 2.1. Obviously, we want this in kilometers, so we're going to change it to meters. This is because this is in centimeters, this is in centimeters. How do we change that to meters? Well, we're going to divide by 100, and then to get from meters to kilometers, there's 1,000 meters in a kilometer, so we're going to divide by 1 to get it to 10.5 kilometers. Okay, so that's exactly what I've done. I've divided by 100 to get to meters and then divided by 1,000 to get to kilometers. If the accuracy of the measurement is to the nearest 0.1 of a centimeter, then what is your percentage error to your answer in question 1, your percentage error? So we could do all this again, or we could say, okay, because this is to the nearest 0.1, then the error is always half of that, remember? The error is to the nearest 0.1, therefore the error is 0.05. The measurement is to the nearest 0.1. I should write that in there. That should be the measurement that took it over. The measurement is to the nearest geez, everything takes it over. That's probably why I had error there in the first place. Okay, so the measure is to the nearest 0.1, therefore the error is 0.05. So how do we calculate the percentage error? It's always the error over the actual distance and then times it by 100 to get to a percent. So that's exactly what I'm going to do. I'm going to look at this. It's always that percentage error is the error over the actual times 100 to turn into a percent. So it's going to be 0.05 over the 2.1, and then we're going to turn into a percent. Now you might be thinking, well, don't you have to find out, hasn't it got something to do with this 10.5 kilometers? We could go back there and find out what this would be using this, but we're timesing everything by the 500,000, so we really don't need to do that. So what we've got is 0.05 over 2.1, times it by 100, and we get 2.38% error. That's the error in it. Now, the last one here. Two cities are 72 kilometers apart. How far apart are the two cities on the map in millimeters? Okay, so every now and again, you've got to make sure you read the question properly, which I don't think I have here, but let's see. Now, what we know is that 1 centimeter equals 500,000 centimeters. And from up here, if 2.1 centimeters is 10.5 kilometers, what that means is that 1 centimeter equals 5 kilometers. Okay, so we know that 1 centimeter equals 5 kilometers. We want to know what 72 kilometers would be. So that's exactly what that's what we've written there. We know that 5 kilometers equals 1 centimeter. What would 72 kilometers? And again, I'm going to do this thing that we're going to take this back to 1 because that's the unitary method. So we've divided by 5 here. So we divide by 5 there and get 0.2. And then we times by 72 on this side and times by 72 on this side. We go back and read the question. How far apart are the two cities on the map in millimeters? And we realize that, yes, I have made a mistake. In millimeters, that would be 144 millimeters. So make sure you read the question unlike I did. And that would give you the correct answer. Okay, thanks.